Okay, what I want to have you guys do today is to practice finding the equation of a data table. Okay, I don't think this is worth doing a whole Nearpod over. I think you'll catch on. What I did is I have a graph here, and I have the points on the graph 0, 3, 2, 4, 4, 5, and 6, 6. Okay, I have the same coordinates on that graph over here on the data table. Okay, so 0, 3, 0, 3. 2, 4 is my second point, and 2, 4 is my second point on my data table. 4, 5, 4, 5, 6, 6, here's 6, 6. Okay, what I want you to be able to do today is to find the equation from a data table instead of from a graph. But I think if I show you the relationship, I think you'll catch on to this. Okay, think for a minute. The slope of a graph, which is a half in this problem, it was the rise over the run. Okay, it was the rise over the run because we went up 1 over 2, up 1 over 2, up 1 over 2. Okay, I want you to look at that idea in the data table. Notice when we went up 1 over 2, look at our y-coordinates for a minute. See, we went from this 3 to 4. We went up 1 in our y-coordinates. We went from 3 to 4. And look over here. That rise of 1 is really going from 3 to 4 in our y-coordinates. And then our run, if you notice the x-coordinates of your points, we have a 0 and a 2. Our run took us from x equals 0 to x equals 2. So our run was because we went from 0 to 2. Look at the data table here, y'all. 0 to 2, we increased by 2. Okay, so what I'm trying to get at is when you rise 1, that means your y-coordinates go up 1. And when you run 2, that means your x-coordinates are increasing by 2. And it keeps doing this. It keeps doing this on the data table. The y value goes up by 1 again. The x value goes up by 2 again. The y value goes up by 1 again. The x value goes up by 2. Just like it continues to go to rise 1, run 2, up 1 over 2, up 1 over 2. Okay, you get it? It's the same idea. It's just in a different form. Okay, so what I'm trying to get at is that the slope of a data table, instead of being rise over run, it's going to be the change in your y values over the change in your x values. The y's are changing by 1. The x's are changing by 2. So the slope would be a positive 1 over a positive 2, okay, which is a half. We'll look at another example in a minute. Okay, so that's the first thing. Slope of a data table is change in y over change in x. Okay, the second thing to notice is that the y-intercept of a graph. Think about the y-intercept for a second. It doesn't matter where your y-intercept is. Okay, a y-intercept is where a line crosses the y-axis. Think about what is true about every point on the y-axis. Okay, this right here is point 0, 3. This is point 0, 5. This y-intercept, if it was a y-intercept, would be 0, 6, 0, 7. Do you notice what's always true about the x-coordinate? Okay, the x-coordinate of any number on the y-axis is going to be 0. So when you have a data table, the y-intercept is going to be the y value across from x equals 0. Make that darker. Okay, the y-intercept of a data table is the y value across from an x value of 0. Okay? Let's do an example. And I will say this, sometimes they won't give you the 0 on the data table. So you have to use your noggin and kind of work backwards, because we're going to do an IXL lesson over this. Okay, let's do another example. Okay, I just want to know the equation of this data table. Okay, to find the equation of a data table, the slope is the change in y over the change in x's. Okay, the change in y. What's happening with the y values? Notice they're going down 2 every time, from 20 to 18 to 16 to 14. Okay, the y change is -2. Okay, the x change, look at the x coordinates, the x values as you go down the data table. 2 to 3, it goes up 1. 3 to 4, it goes up 1. 4 to 5 goes up 1. Okay, the change in x values is a +1. So the slope would be change in y over change in x. It'd be -2 over +1. Simplify that just like you simplify slope of a graph. -2. Okay, the y-intercept is the y value across from an x value of 0. And unfortunately in this problem, they don't give it to us. You know what? We're going to just count backwards and we're going to figure this out. Okay, look right here. Think counting, I would just count backwards if it was me. 5, 4, 3, 2. Okay, I want to have a 0 on the left side, right? 5, 4, 3, 2, 1, 0. Okay, I want to have that x value of 0 to think about. Okay, I just need to count backwards with my y values. 14, 16, 18. Do you see that's going up 2 backwards? Keeps going up 2. Okay, 20. Add another 2, you get 22. Add another 2, you get 24. And that's what we need for the y-intercept. It's the number, the y value that's across from x equals 0. So the y-intercept is 24. And now it's just putting it together, the equation. Remember, the slope goes in front of the x, and the y-intercept goes after the plus, and the slope was a -2, and the y-intercept was a 24. So the equation of this data table is y equals -2x plus 24. Okay, do the best you can on this. The IXL lesson over this is really good. Okay, it's really good. It explains things the same way I do. Don't worry about getting over 80, because you need to know some other things that I haven't taught you yet. I'm trying to just get to the basics at the moment. If you can get even in the 70s and 80s on that lesson that I'm going to assign, it's going to be perfect. Okay? Because again, I haven't taught you some of the things that I should have for you to get to like 100 on that. Okay, but big idea. Slope of a data table, change in y over change in x. The y-intercept of a data table is the y value across from x equals 0. Sometimes you have to count backwards to get it. Okay, keep me posted, guys. I want to help you if you have questions on this.